To find the molecular geometry, or shape, for H2S, we'll start with a Lewis structure. Here we've drawn the Lewis structure to show the atoms and then these lone pair electrons spread out. And that makes sense with what we know about valence shell electron pair repulsion theory, that these electron clouds around the hydrogens and then those lone pair electron clouds or orbitals, they're going to spread out. But we still need to look at the three-dimensional structure to really understand the molecular geometry for H2S. Here we have the H2S molecule in 3 dimensions, and it's a little bit different than what we saw on the screen, which was flat. We have sulfur in the center, that's yellow, and then the 2 hydrogens, they're white, and on top, those dots, those are electrons. So we have 2 pairs of valence electrons. And you can see that it's not flat like we had in the Lewis structure. There's another way we can find the molecular geometry for H2S, and that's to use the AXN notation. Here we don't actually have to visualize or know that 3-dimensional structure beforehand. A, that's the sulfur there. X, that's the number of atoms bonded to the sulfur, that central sulfur. We have 2 hydrogens, so we'll put a 2 right here. And N, that's the number of non-bonding electron pairs. We have 2 pairs, so we'll put a 2 right here. Now you could memorize that this AX2N2 is a bent molecule. Or, if you're allowed to, you can look it up in a table. So going down our table, we have AX2, AX3, AX2N here, and then way at the bottom, AX2N2, which is a bent molecule and is in bond angles of 109.5. So for our bent molecule here, we could draw our bond angle, that's this angle right here, of 109.5. It's helpful to think of it both ways in terms of the valence shell electron pair repulsion theory and then to check with the AXN notation. This is Dr. B with the molecular geometry for H2S. Thanks for watching.